welcome all of you and say good evening. And I also want to welcome our virtual audience. Thanks for joining us. My name is Justin. I'm a product manager for ArcGIS Enterprise, and I'm joined today by my colleague Chris. Today we're going to talk to you about cloud deployment options and cloud native services. But before we begin, you might have all seen this before. We would really appreciate your feedback. And regarding this session, we go back and we review each feedback piece that you all give to us. It helps us improve this session for future conferences. So if you like something, dislike something, something didn't make sense, something really resonated, let us know. We'd really appreciate that. But kind of getting through here, I'm going to go ahead and go over this little quick agenda. We're going to quickly go over the cloud deployments and the tooling options available to you. We'll talk about the cloud store architecture, and we'll also go over some cloud services. And then we're going to leave about 15 minutes for Q&A for you at the end. So let's get started. Deploying ArcGIS Enterprise on Windows and Linux in the cloud essentially means running the software on virtual infrastructure provided by a cloud vendor instead of physical servers on premises, like in your office, maybe in a data center or something like that. This approach falls under infrastructure as a service, where you provision virtual machines, storage, and networking in the cloud, and then you install ArcGIS Enterprise on top of them. This is distinct from software as a service, or SaaS, like ArcGIS Online, where Esri hosts and manages everything for you. And so running in the cloud can offer considerable business and technical advantages. Cloud platforms provide on-demand scalability, meaning the ability to easily add and remove compute resources to handle your peak GIS workloads, such as seasonal surges. It offers high reliability and disaster recovery options, as their data centers have built-in redundancy across multiple availability zones. And it could be a shift from upfront capital expense model to a more flexible operational expense. I've also heard things that customers are also looking to reduce their burden of hardware and software maintenance while unifying their GIS hardware infrastructure into the rest of their organization. And lastly, with the increased cost and demand for disk space as well as DBMS resources, customers are always looking to maximize the value of storing their data via cloud native services. So switching to the cloud means you don't have to buy and maintain physical servers. The cloud vendor takes care of hardware failures, power, HVAC, expansion, giving you time to focus on the software and the data. So with ArcGIS Enterprise, our customers always control the GIS and the data. Cloud choices simply determine how much infrastructure and operations they want to run themselves. And so the key takeaway that I want you all to kind of get away from the next few slides is deploying and running ArcGIS Enterprise in the cloud follows a clear and layered approach. I like to think of it as a pyramid. The foundation we'll start with is deploying in any cloud. We'll talk about the different types of cloud tooling available to deploy the software. And at the top, we'll talk about the specific cloud native services that ArcGIS Enterprise integrates with. So for Windows and Linux, ArcGIS Enterprise is cloud agnostic. As long as the system requirements are met, you can deploy on any cloud provider your organization uses. This flexibility allows you to align with internal cloud strategies and standards. Esri does provide tooling for deploying on both Windows, Linux, and Kubernetes environments. On Windows and Linux platforms, there's tools like the Enterprise Builder, Chef, PowerShell DSC, and these things help automate and standardize deployments. And for ArcGIS Enterprise on Kubernetes, this runs cloud natively and supports managed Kubernetes services like EKS, GKE, and AKS. An example when deploying in the cloud where we have maybe a new GIS admin, they might use ArcGIS Enterprise Builder for a quick single machine pilot installation to kind of just feel it out and to see what they're working with. And for more automated enterprise setups, especially those multi-machine or scripted deployments, you're going to be using Chef or PowerShell to provide infrastructure as code style installation of the ArcGIS Enterprise components. Beyond a base deployment, Esri provides tooling that automates provisioning and installations in AWS and Azure. These utilities reduce manual work and help teams deploy faster and more consistently. And diving more into this, the Esri tooling focuses on the clouds that our customers are using the most right now with AWS and Azure. Elsewhere, we meet you where you are by integrating with your provisioned infrastructure. Here are how the cloud native tools for Windows and Linux work. So we have Cloud Builder for AWS, which is a command line tool for automating deployments in AWS. You run it with a JSON configuration or parameters indicating your desired architecture. And it launches the necessary AWS resources, so like your EC2 instances with the appropriate AMIs, load balancers, security groups. And then it installs and configures ArcGIS Enterprise on top of that. CloudFormation templates handle the infrastructure as code layer, allowing you for deep customization and version control of your deployment architecture. You can treat the template as code, modify instance types, subnets, additional storage, and then deploy consistently across accounts or regions. And for Kubernetes deployments, we use Helm charts and Esri provided deployment scripts for standardized installation. In most cloud scenarios where you're using ArcGIS Enterprise base deployment, you'll likely use an ArcGIS Enterprise Cloud Builder to deploy with just a few clicks, rather than manually creating VMs and going through the installers, what we used to call next finish. But just remember that you can separate the infrastructure deployment side from the software deployment side as needed. So CloudFormation for the infrastructure, and then Chef or DSC or those manual installs for ArcGIS Enterprise itself. Then Esri also offers Cloud Builder, which unifies both of those steps if you prefer an end-to-end guided workflow. And once Enterprise is deployed in the cloud, you can take advantage of cloud storage, database, and analytics services. Some examples of these include cloud object storage for data lakes, manage relational databases like RDS or HANA, cloud data warehouse platforms for scalable analytics. Chris is going to expand on this a little more later in the session. And so this summary really brings the layers of the pyramid together. Deploy in any cloud, use Esri's tooling to simplify provisioning and install the software, integrate with cloud services for scalable storage, databases, and analytics. And the key takeaway here again, flexibility. ArcGIS Enterprise runs where you need it with the tools that adapt to your environment. AWS and Azure each offer additional cloud-native capabilities that enhance ArcGIS Enterprise, and we're going to talk a little bit more about this. So getting into integrating cloud-native services, most of you are familiar with user-managed data stores. These are owned and operated by users who control configuration, performance tuning, security, and maintenance. System-managed data stores are fully maintained by the platform or service provider, handling the provisioning, the scaling, security, and backups with minimal user effort. The key difference lies in responsibility. System-managed prioritizes convenience and automation, while user-managed prioritizes control and customization. At 11.4, a base deployment of ArcGIS Enterprise now requires an object store to be configured with the hosting machine. This could be provided by the ArcGIS Data Store or by a system-managed data store like S3 or Azure Blob. And for quite some time, Portal for ArcGIS has allowed you to configure its content store in a system-managed data store. Portal manages the metadata, permissions, sharing, access, while cloud storage stores the actual files and data in a secure, highly available, durable cloud storage instead of on local disks. And for ArcGIS Server, you've been able to store your config store in these same system managed data stores, but there was one last piece. That is the server directories, the cache, output, and jobs. And now at ArcGIS Enterprise 12.0, these can also be stored here. This approach is especially beneficial when you plan to scale beyond a single machine or you're looking to create a highly available site. System managed storage doesn't have to mean another file server VM. We can push these stores into cloud-native services, and we're excited to have released this as Chris and I have been receiving feedback from many of our high availability customers deploying in the cloud who historically have had choices for the config store, but have needed a file server for server directories. And so with this, I want to go ahead and give a demo here. So if we don't mind, let me minimize this. Thank you. Okay, sorry about that. So I'm going to show you something new here in ArcGIS Enterprise 12.0 that fundamentally changes how ArcGIS Server runs in the cloud. Historically, even in AWS or Azure, ArcGIS Server still depended on a standard file server for its operational directories, right? Another VM and another potential point of failure. In 12.0, that dependency is gone. So what we're looking at here is the AWS console, and I'm going to go ahead and go into our S3 bucket. And this is being used directly by ArcGIS Server. So what you're looking at here is So what you're looking at here is not a file share. These are cloud objects that are being stored directly in this service. That means that there's no file server and there's no VM. So directories like the cache, the jobs, the output, which used to live on a shared file system, now live directly in an object storage. That removes an entire class of infrastructure from the architecture. Once removing the file system, you can also remove file-based coordination. So in cloud deployments, ArcGIS Enterprise relies on managed cloud services for that instead. So for example, services like Amazon SQS are used for queue-based coordination, replacing patterns that historically depended on shared directories. And managed key store values like DynamoDB are used to track distributed state reliability without relying on locks or shared disks. And the important takeaway in this again is the file server is gone. Coordination and state move to cloud-native services designed for scaling and resiliency. And this also aligns with where modern GIS content lives. And so with the introduction of hosted 3D scene layers and tile-based services at 11.4, these are backed by object storage as well. So here we would see inside the input folder, Chris. What do you look for? The CPD. The inputs. Yeah.
Go to config store.
Where'd it go?
There you go.
Utilities.
Just use that.
And so these are typically what are stored here are large read-heady data sets that don't belong on file shares. And now they're referencing this S3 bucket. So let's take a look and see what it looks like in ArcGIS Server Manager. So when I navigate over here to ArcGIS Server Manager in the config store, we can see that this is selected as an Amazon Web Service storage, which has been around for a few versions now. But if I go to the directories, you will see that the cache, the jobs, and the output, all of these locations are now referencing cloud stores. The system directory is a local path on each machine, so not something that needs to be shared between machines. This is used for uploading scratch space before moving it to shared storage, as well as a repository for downloaded service definitions and data that are pulled from shared object store locations. So even on a single machine Windows deployment, ArcGIS Server no longer depends on a shared file system. That means fewer VMs, fewer failure points, and a much cleaner foundation as customers scale towards high availability. So let's zoom out and summarize. Historically, even in the cloud, looking at the image on the screen, ArcGIS Enterprise still depended on a shared file server for ArcGIS Server directories. Another VM, another failure point, extra operational overhead. But with ArcGIS Enterprise 12.0, that dependency goes away. Server directories no longer live on a file system, job coordination moves to managed queue services, and cache and system content move to object storage. That's what the demo showed, and the key thing wasn't the storage bucket, it's what's missing. There's no more file server VM underneath this architecture anymore. Fewer moving parts, fewer single points of failure, and a much cleaner foundation for scaling ArcGIS Enterprise in the cloud. This isn't Kubernetes only, this isn't for high availability only, it's a core architectural shift in how ArcGIS Enterprise runs in the cloud.
All right. Thanks, Justin. So next, we're going to start diving a little deeper into specific cloud services and how we can utilize those integrations to power our GIS services, beginning with cloud object storage. Now, cloud object storage is something we've supported with ArcGIS Enterprise for quite a while now. It's been long running. We support a lot of different storage services, including Amazon's S3, Google Cloud Storage, Azure Blob Storage, and others. And while navigating the console or listing objects via the command line may appear very file system-like, it's distinct from block storage like EBS volumes in AWS. Now, from a best practice perspective, and this applies across the board for cloud services, we want our data to be co-located in the same cloud provider that our ArcGIS Enterprise system is deployed on. This minimizes latency and maximizes performance of those dependent GIS services. Now, in terms of how we're able to connect to these object stores, we support a lot of different authentication schemes for each provider. In the case of AWS, Google Cloud Storage, and Alibaba, those are access key pairs or HMAC keys. In AWS, we support IAM roles. And most recently, we've added support for more modern authentication schemes in Azure Storage, such as shared access signature, service principal, and user-assigned managed identity, in addition to the storage account key method we've always supported. So the question remains, how can we actually use this cloud object storage in the context of ArcGIS Enterprise? Now, as Justin brought up before, we have our system managed data stores, and we have the option to utilize cloud object storage for that purpose. Another option is as a cache directory for ArcGIS Server or ArcGIS Enterprise on Kubernetes. That would store our cache tiles for our map and image services. These caches can be very large, so object storage is a very cost-efficient and scalable solution for these huge data sets. Cloud storage can also be used in support of scene layers, raster and vector tile layers, and imagery layers referencing a mosaic data set. We can use cloud storage as a backup location to write backups directly to the cloud, something like an S3 bucket or a GCS bucket. And finally, we can also configure the cloud object store to provide the object storage Got those switched up on you. The system managed object store in ArcGIS Enterprise on Windows, Linux, and Kubernetes can be configured to take advantage of these scalable solutions. So as a quick practical example, let's look at a few ways we can publish with hosted and by reference scene and tile layers and see where that data ends up following the publishing process. Mirror. There we go. So here, I've published a number of different services, and we'll go through the data locations for each. Looking at my 3D tile layer first, we see that it's a somewhat rudimentary example of Boston buildings published in color. If we look at that service in the REST endpoint, or sorry, the admin API, we can see this path in the cached store. This data lives under the ArcGIS cache prefix and has a unique service ID associated with it. Switching over to our S3 bucket and stepping into this ArcGIS cache prefix, we can see that same ID reflected in here. If we look in here, we have our tileset.json, the equivalent of root.json in a scene layer, and we have our actual tiles extracted under this prefix. Visualizing this layer in Scene Viewer, all this information is being served to the client directly from S3 via the tile handler in between. Given the internet speeds, we may have a little bit of a delay, but we can zoom, pan, and visualize this information without having a direct dependency on that block storage attached to the VM running ArcGIS Enterprise. Now separately, we can go through a publishing process. If we go back to my content and we want to create a new item, we'll pull up our data set for, let's take the bridges scene layer. We'll add that SLPK, and we want to create a hosted layer out of it. Clicking through, hitting save, it'll begin that publishing process in the background. Now, like this 3D tile layer we just saw, it's going to extract that information, persist it in our system managed object store, and we'll be able to visualize that via that mechanism. As I didn't point out, but as I'm pointing out now, the scene layer package in question here is about 230, 240 megabytes. Not incredibly large by any means, but what if we had a few terabytes of information? Do we really want to take that processing through the enterprise system itself and having it extract all that information into this object store bucket? I would say not. So the second option for publishing, we can take the by reference route. And we'll use ArcGIS Pro to extract that scene layer package, push it via the Cloud Connection file to the S3 bucket, and publish by reference. That example I've already done for us through the magic of demoing, and I've published the San Francisco scene layer. Now, if we take a look at this path in the cached store, we see that we're referencing directly an I3S REST location. Now, stepping back into our content, we see that this process for publishing is still ongoing. But if we take our content page and visualize our other scene layer that I published in the background, the experience from a user perspective is no different. It's all about how we set up the plumbing behind the scenes to visualize this information. Taking a step back to our S3 bucket, I've actually set this up in a separate location. If we look in this cache bucket, we have our San Francisco I3S REST. And so this information lives outside of the hosted data boundary, and we no longer have to accumulate that information when we run operations like a backup and restore, for example. So stepping back into the slides, so let's look at some of the benefits that can come out of utilization of cloud object storage. We see that we can save on storage costs. The equivalent cost of block storage versus object storage is about a quarter expense-wise. We have high scalability. We no longer have to manually increase the size of our EBS volume attached to this VM just to accommodate large publishing events. And we also have that backup and restore performance benefit, where since we're not backing up potentially terabytes of data, we can back up and restore much more quickly and keep that boundary between system managed and user managed data. So now that we've learned about the cloud object stores, let's step into cloud databases for a moment. We've been able to leverage cloud databases for also a very long time within ArcGIS Enterprise. When we talk about cloud relational stores or cloud databases, we can enable enterprise geodatabases within them. They support storing and managing your full suite of data sets that ArcGIS Enterprise interacts with from a relational perspective. When we talk about what do we support, really we have our core database technologies, and we can likely integrate with any of the cloud-based database as a service offerings. Here's a list of what we currently support. And if there are others that come to mind, we'd love to hear your feedback on what we should push into next. An exciting feature to point out is that in ArcGIS Enterprise 11.4 on Kubernetes, we added support for use of a database service as the system relational store. That's used for both settings, data, and configuration storage within the organization, along with hosted feature layer data. In the future, we hope to expand this support for Windows and Linux as well, as a replacement for the ArcGIS data store configured as the relational store. So when it comes to relational stores, some of the benefits that they offer, they decrease the barrier to entry in terms of manageability, scalability, and availability. Administrators can take advantage of cloud provider mechanisms to manage provisioning, upgrading, patching, and backing up and restoring the database instance or cluster itself, which eases administrative toil. This isn't to suggest you don't need a DBA or a trusted partner to manage these database instances, but the time and complexity of normal maintenance is significantly reduced. It's also much easier to scale the storage capacity. It can be scaled up and down with just a click, or you can enable storage auto-scaling on the instance itself. This allows the service to detect when the space is running low and automatically scale up until it reaches a threshold that you can also define. They're also scalable in terms of CPU and RAM. While provisioned services can scale manually, they won't react to spikes in traffic or request volume. Many cloud providers offer serverless options, like Amazon Aurora Serverless or Azure SQL Database Serverless. And these can automatically scale compute resources to accommodate unpredictable workloads and charges you for what you use when you use it. Finally, these database services are built for resilience and offer a wide range of availability-focused features that can be opted into. These features increase your redundancy and reduce your downtime based on your business needs and related SLAs. Regardless of which of the two options you choose, serverless or provisioned, and what features you opt into from an availability perspective, ArcGIS Enterprise doesn't treat them any differently. And so we highly recommend, when you're operating in the cloud, that you take advantage of these offerings. Now, the third and final type of cloud service we want to cover are cloud data warehouses. Just curious, out of a show of hand, is anybody in the audience using cloud data warehouse-based services in their organizations? All right, we got a couple. Maybe next year we'll ask the same question, see how much we've increased. So cloud data warehouses themselves are designed to support storing and analyzing large volumes of both structured and unstructured data. These offerings solve a lot of the challenges encountered when using hardware-based solutions to warehouse an organization's troves of data. Currently, we support 3 of them within ArcGIS Enterprise, to include Amazon Redshift, Google BigQuery, and Snowflake. These allow users to establish database connections from ArcGIS Pro and use structured query language to define analytical or summary query layers that help to answer questions like, where is the slowest moving traffic area between 7 to 9 a.m. in Raleigh, North Carolina? Or how was precipitation distributed over time in San Diego last year? A common misconception for our support of cloud data warehouses is that the data has to be moved into ArcGIS itself, copied out of the cloud data warehouse. Now, we do offer that as an option, but we can also run that query every time the service is accessed, or we can persist those query results separately, and we'll get into the specific mechanisms in ArcGIS Pro in a moment. And then in terms of data treatment, you can take point data and easily aggregate it into feature bins with summary statistics computed for each one. This allows you to easily detect patterns from tremendous volumes of data. ArcGIS Enterprise also provides flexibility in how you'd like the software to access this data. And for that, let's step into the next portion of the demo. So for this portion, I wanted to take a look at our other data item that I've registered here. When we look at the BigQuery data store item already registered with the hosting site, I've published 3 services off of this single data set. We're targeting that question of the traffic between 7 to 9 a.m. in Raleigh, North Carolina. To get this installed, we had to go back to our ArcGIS Enterprise machine and look at the installation of the driver that provides the binaries necessary to connect to BigQuery itself. If we look in our installed programs, we'll see that, slowly we'll see. The BigQuery driver necessary for communication, the 64-bit driver necessary from both ArcGIS Pro and ArcGIS Enterprise has already been installed. Now switching back to our web view, we can go back to our content tab. And from here, I have multiple Raleigh services published. They'll show up as feature layers, as you're used to, but each of them represents a different method of publishing this information from the cloud data warehouse. The Raleigh slow traffic runs that query every time via BigQuery. The computation is done on BigQuery's analytical engine, and we are able to visualize the results. The second one I published was the slow traffic MV for materialized view. This still takes advantage of the analytical capability on the Cloud Data Warehouse side, but it will persist the results of that query in a separate table temporarily. When we query, if the underlying data set hasn't changed in the previous span of time, it'll just give us that smaller data set and it'll return it much more quickly. This is important when your data is changing, but we don't want to repeat a very large query or a very costly query time after time. And then finally, the third methodology was the use of the snapshot. What we've done there is we've taken the result data set of this query and we've moved it into the relational store. The relational store, being co-located with the ArcGIS Enterprise stack, gives us very fast response times. And so let's take a step into the web map that I combined all three of these in, and we'll try to see that in real time. Since this is a small data set, relatively small, to begin with, the rate at which we're getting these responses is very fast. Now, if we take a moment to disable these, clear this out, and I'll reload my web map. After I save. Oh, one moment. All right, now we're in business. So now I haven't loaded any of these feature layers. If I start enabling them, we'll start with the original query that's run on the server side. We'll wait for those responses, and we see anywhere between 2 to 3 seconds on a response. Not bad, but I think we can do better. Now let's see what happens with the materialized view layer. Looking at those queries, roughly, actually about the same amount of time. This query doesn't take a long time to process from the analytic engine perspective, but I still think we can do better. With the snapshot, like I said, we've moved this data into the relational store for the system. And so now we see a significant reduction in the amount of time taken to render that response. Where this can be advantageous is for relatively static data that updates maybe daily. We can automate the refresh of this snapshot. And so we can use an external automated script, if this is updating hourly, to refresh that data while our client response times are still significantly faster than the other two methods. Stepping back into our slides, I just want to recap the different methods of publishing these services. So as we walk through, when sharing layers to ArcGIS Enterprise, we have 3 distinct options for publishing a map image layer or feature layer using a Cloud Data Warehouse-based data set. They can access the data directly, which returns live results at the expense of performance, as the base tables are queried before returning that response. Instead, we can choose to create a materialized view or a snapshot, which is going to increase our performance for complex queries. When the materialized view is utilized, the query results are stored in the data warehouse and automatically kept up to date as the underlying data changes, with just a small delay from showing live data. And finally, the snapshot option takes this to the next level and copies the result set to ArcGIS Enterprise. This option minimizes latency as the web layer is no longer accessing the Cloud Data Warehouse directly, but instead queries the relational store dataset. This option potentially could have a large delay in showing live data, but users can refresh that snapshot on demand or even schedule it to be refreshed automatically, beginning in ArcGIS Enterprise 11.3. So In terms of benefits from cloud data warehouses and what we can expect, they offer advantages in terms of huge volumes of data, how we can visualize that data, and how we can get that data within our web apps and web maps. From a cost perspective, you're only paying for what you use, and you don't need to pay for idle resources or upfront costs to get up and running. And from a security perspective, these cloud providers have their controls in place, and they're relatively seamless in terms of authentication, authorization, and goodness gracious. With these combination of factors, these cloud data warehouses are becoming more and more common for organizations operating at a huge scale. But that doesn't mean that other organizations can't begin on that journey and take advantage of those features as well. And finally, in summary, if your ArcGIS Enterprise is running in the cloud, you should be using cloud services. These services include cloud object storage for storing backups as well as data in support of web layers with extremely high durability and reliability. Cloud data warehouses as a relational database, including your enterprise geodatabase needs for scalability. And cloud data warehouses as a storage location for your large volumes of non-transactional structured and semi-structured data, giving you endless possibilities. And finally, when you get all these things plumbed together, there's a high opportunity that you can see manageability and cost savings as an advantage as well. And I think we've got some resources here in terms of opportunities to kind of jump off from a lot of these points. I'll leave that up for a moment. One last ask. We always try to improve upon the session, dive into topics that you guys maybe wanted more content on, had more interest in. So if you'd fill out the survey, that would be much appreciated. And with that, I think it's a good time to open it up for questions. Thank you all.
I have a question regarding the cloud data warehouses. So the organization that I work with has a use case for essentially utility network data warehousing. And what they're doing right now is using Amazon Aurora and essentially a separate cluster to replicate their utility network data. The key driver of that decision is they wanted to decouple downtime between their ArcGIS Enterprise and this data stream. So my question is, with cloud data warehouses, are there opportunities to essentially decouple the maintenance and downtime to other the enterprise GIS system and data warehouses? Or are they kind of all considered one unit, one environment?
Yeah, so I'll shorten the question significantly. Correct me if I missed any points. In a particular use case where we have utility network data and some other kind of external dependencies, it's not solely a database cluster that ArcGIS Enterprise depends on. Is there an opportunity within the cloud data warehouse space to decouple downtime and be able to maintain accessibility of that data through maintenance of ArcGIS Enterprise? Perfect. So is this using the utility network model specifically?
Not necessarily, but it is calculating additional fields from the utility network, essentially spatially derived fields outside.
Okay. So it is indirectly using the utility network model. And so with that context, I would say that there could be an opportunity for offsetting that specific database cluster that's being replicated for that purpose, or at least kind of appending that data into that database. I don't think that this would be the perfect answer to that, where it would actually get rid of the necessity of Aurora. Given the other dependencies in place, they would also have to be able to query that directly. And so I think there are probably some unknowns there. there could also be opportunities as well. It just depends on a lot of the kind of back-end factors. Maybe we can follow up with that a little bit.
I did a cloud deployment in Azure using the new Cosmos DB stuff. I created a site and it was all working fine and I published some managed services to it. I added a second node to the site, and what I noticed was when machine joined came up into the Evan API, looked like it was all good, but there was a difference in the local ArcGIS system drive, both machines. So the primary machine had all of the ArcGIS, all of the access folders on it. The second machine did not. I could see that the sources were spun up on the first machine with that maintenance. So is that expected behavior, or is there something that you have to do in the second machine to go back to Cosmos to bring down the storage and this sort of stuff?
That's a good question.
Yeah, so the question was, customer yourself had deployed a Azure deployment using the new architecture, and post-deployment had added a second machine, and the ArcGIS Server instances seemed to be out of sync from a kind of configuration perspective. That's something we'd want to take a closer look at and understand a bit more. I know that we did have some scalability testing in place. But yeah, it'd be good to investigate. Mhm. Okay. And we had, when you first deployed that, it was using the cloud store, and then you just went in and clicked increase for a second machine. Was it a standalone or federated server site? Okay, yeah, let's follow up with that. If we have time, if you have time tomorrow, it'd be a good thing to bring up in the tech zone, and we could follow up there, because that would be unexpected. I'll put it that way. Correct. Thank you.
We're going to take a question real quick from the audience and we'll get back, or from the virtual audience, and we'll get back. So there's a question here. Are there any recommended usage stats like views over time, or expanding or partnering with the cloud becomes advantageous versus trying to keep and manage it all tightly on-prem? I'll give my answer on this, and then Chris will probably have a perspective. I don't think there is. I don't think there's a one-size-fits-all or a cookie-cutter approach to when the cloud will be beneficial for you. I think there's a lot of factors that come into this. I think usage is definitely one of those driving factors outside of cost, but also what is your organization looking to do in general with its infrastructure? If it's going towards the cloud, again, we provide that flexibility to go along with that. If you guys are looking to stay on-prem, to kind of have that little more control over your environment, that's something that you're going to want to kind of stick with as well.
Yeah, absolutely agree. And so the commonality between on-premise and cloud deployments is we're still running some level of compute, memory requirement. We have a certain kind of engine running everything. It's typically more of an organizational push, as Justin said, to move towards a cloud provider or move things from a cloud provider back to on-prem. And so there are advantages to running in a cloud provider depending on your data center's capabilities, like redundant power, redundant network links, all these different things. Typically, the different availability zones in AWS are going to be pretty top-notch. And so the resiliency and reliability of your data center can also be a motivator to push towards the cloud. It's not always a direct kind of cost analysis. This one's cheaper than this one because the total cost of ownership is sometimes difficult to tease out with all those kind of additional infrastructure costs. But yeah, I couldn't say there's a clear line in the sand we could draw to say, oh, you should be in the cloud, but you shouldn't. It's really a multifaceted decision.
So we're working with snapshots. The last part about the cloud data warehouse. My question is, when you have that copy of data of the query result, where are the results stored? Maybe in the object store. And the second question is, what if I want to refresh the results? Maybe I have new records.
So the first question was, when working with a snapshot for a cloud data warehouse-based feature service, where is that snapshot stored? And so that would be stored as a table in the relational store. So the ArcGIS data store that's configured with the hosting site, we would store that data set, that result data set, directly in the relational store for the system. So if you have a single machine-based enterprise deployment, it would be technically on disk right there. If you're using a kind of distributed architecture, then we would be storing that on the machine that ArcGIS data store is configured on for the relational store. The second question was, if we're looking to refresh that snapshot, where would we do so? There is scheduling available within, I want to say it's Portal Home, when a feature layer that's based on a cloud data warehouse is published as a snapshot. But I'll take a look at that after this and I'll follow up with you.
Google Cloud and other like sites, cloud sites that are data to us. Do you use like object storage with Google Cloud, or is it kind of just you like spin up a server and that's kind of like use the file directly on that server, so you're still kind of using a server for files. Yeah, is the object storage kind of just you got it in the US?
Yeah.
So for other clouds, it's kind of like they just post all the servers, but otherwise kind of like on-prem.
So the question was, when we're operating in Google Cloud or GCP, are we able to take advantage of this new architecture? Are we using object storage in Google Cloud specifically? Right now, we do not have the kind of overall integration for the architectural shift that we made. We're interested if that demand is kind of there, for sure. Now, in terms of user-managed object storage, we can absolutely register a GCS bucket and use that as a location for by reference data. It just would not support the hosted model as of right now.
Awesome. Yep.
When it comes to the use for the directories, 11 items are directories in a file, 12 more. Is there a migration path for the upgrade of those
That's a great question. So he was talking about going to from 11.5 or maybe a previous version up to 12.0, and you want to take advantage of this new architecture. Is there a migration path? At 12.0, there is not a migration path, but we are working on that, so there will be one here in the future for you all. If you are looking to do that, let me know. Chris does have a workflow that we can share with you that will help you get to that point, though. Yeah. What was the?
So the question was, when will we support AlloyDB on Google Cloud? We actually do have support. I didn't include it in the slide because it is less tested, I would say, on Windows Linux, but we do have support for AlloyDB in Kubernetes. That's something that we are looking to expand our kind of testing coverage just so we have high confidence in it. But we do support that as the system managed relational store on ArcGIS Enterprise on Kubernetes. So qualitatively, I would say, yes, we do. The only one that comes to mind in terms of the clustered kind of auto scaling of capable Postgres instances that we can't support is Azure's for the system managed relational store. It uses a different kind of protocol at a very low level, and their sharding pattern kind of messes with our hosted feature layer stuff. So there's some conversation surrounding that going on, but at this point, AlloyDB is tested for Kubernetes specifically.
How does that work with WebGIS DR? Is there any issues with that, or is it all happy?
So the question was, with this shift architecturally from file system based shared directories into the cloud service based model, are there any impacts to WebGIS DR? And so with WebGIS DR, we are version locked, right? We have to restore to the same version that the backup was taken from. From an ArcGIS Server perspective, we are actually still persisting the config store in the same way that we have been, because we're still using DynamoDB with an S3 kind of backer. For the queues, we are persisting them a little differently, but they are going into either the backup location on the file system that you define, or we can send those directly to S3 blob storage in the background. So there is no direct impact to WebGIS DR. We put handling in for that in the 12.0 release.
Any last questions? Well, Chris and I will, oh, one more, go ahead. Going to the cloud cost shocks. Can you maybe elaborate on what you would define that as?
I can say that, yes, we have absolutely heard feedback that there has been sticker shock, but I would say that more goes into the complexity of defining your total cost of ownership more often than not, than it truly is exorbitantly more expensive on either side, has been my kind of high-level experience.
And I would say too, I know a lot of cloud providers offer some type of prorated discounted rates depending on your organization. So it's important that you kind of shop around in a sense and see what they're offering for you and your organization that you can take advantage of. Any other last questions here? One more over here in the corner, all right.
So the question was in terms of customers moving to Azure and looking to configure their kind of web tier. Obviously, we have the option to deploy with web adapters, which is our kind of Esri managed solution. Azure themselves have the application gateway, which is what our cloud builder automation uses. The only instance where I've heard customers go from an app gateway back to web adapters, the app gateway is a pretty expensive piece of kit. So I've seen some customers move back to the web adapter kind of model in that sense with public IP assignment. But the app gateway also offers significantly more flexibility if you're adding additional federated sites in the future, if you are wanting to kind of intercept and inspect those packets in transit. It does offer a lot of capability that the web adapter itself does not inherently offer. So I think there are benefits to it. If you're not realizing and taking advantage of those benefits, then you may make the kind of argument that web adapters are a simpler, somewhat cheaper solution. But I think it's kind of a case-by-case scenario. Thank you.
Awesome. Well, Chris and I will hang out here for 10, 15 minutes if anybody has any other questions they want to come up to us. And we just want to thank you again for your time and have a great evening.
Yeah. Thank you all.
you.